Hi, everyone. Today, we're going to take a look at how we can do linear regression using SPSS. Now, let's get started. Now, here I have a data set within SPSS that I want to analyze using a linear regression model. Now, when we do linear regression, as you're aware, you have to make sure that you change any variables that are text variables or categorical. You'll want to change them so that they are binary, or you'll want to change them into some number format. So you want to transform those. Here I have gender, which is a descriptive or categorical variable, male or female, and I've converted that to gender binary. So a 0 if it's a male, a 1 for a female. And I've done the same thing for this diabetes field. Diabetes is yes or no, whether or not these folks or this data set, they have diabetes or not. And then I created a diabetes binary field as well, so that I can do the regression analysis appropriately. Again, because in Excel or in SPSS, you can't do regression analysis using text fields or categorical. You actually need to convert those to numbers. So I have my data set here, and let's pretend I want to know if a person's glucose level creates or is correlated or can be associated with their BMI output. So what I'm going to do is I'm going to go to Analyze, and I'm going to click on the regression. And I'm going to do, with this example, I'm just going to do a simple linear regression. Let me move these values all over here. And I want to know that if my BMI, if my glucose level can predict my BMI. So my BMI is going to be my dependent variable, which is the output, the Y value, and my independent or my input is going to be my glucose variable. So what I want to see is whether or not I can predict BMI just solely based on glucose level. Now I'm going to click on statistics. Oftentimes what I like to do is click on the confidence intervals, get the covariance matrices, also get the model fit, which is going to be my R squared value, any R squared changes. Now this will be very helpful when I'm doing a multiple linear regression. So for right now, I don't need the covariance and I don't need the R squared change or really any of the descriptives. I'll just click off of those and click continue. And now I'm just going to get a simple linear regression model summary that gives me the R squared value. And it also tells me what the model is. So can we assume now that glucose does contribute to BMI? Well, if we look at the T-score and the significance level, you can see here that the T critical value is 5.87, resulting in a p-value or a significant level that is less than 0.001. So this shows me that glucose is highly significant in being able to predict my BMI. Okay, so now let's pretend that what we want to do is a multiple linear regression, meaning that we want to assess multiple variables to see if multiple variables affect my BMI. So I'm going to do the same thing that I did before by going to Analyze, Regression, Linear Regression. But now instead of only having the glucose, let me go ahead and add in blood pressure, skin, RDA, and let's just do age. And I'm not going to include any of the gender. Well, let's go ahead and include the gender binary as well and see if that's okay. Now, diabetes, I think, would be very highly associated with predictor of BMI. So I'm just going to go ahead and leave that one out. But you could include that if you wanted to, and if you had a sample data set that you wanted to look at. My point is that I'm just adding the variables that I want to see whether or not they can help predict BMI. So again, my output variable is BMI. All of my inputs are here. Now I'm going to go to my statistics. I'm going to go ahead and click the confidence intervals. I'd like to see the covariance matrix because those can be helpful in determining multiple collinearity, R squared change, descriptives. And I'll go ahead and click continue here, and then we'll be able to see all of that information on our output screen. So we have our descriptive statistics for each of the variables. which can sometimes be helpful when you're looking at this. And I really like the Pearson correlation matrix. So it shows us how the variables are correlated with one another, and you can assess multi-collinearity using your correlation matrix. Now I'm going to go down to the model summary. You can see what the R squared is and what the adjusted R squared is, which is your R squared change. An R square of 0.471. And we can actually look at the coefficients and whether or not the coefficients are significant or not. So taking a look at each of the coefficients, you can see the t-score, the t-metric, and the t-critical value, and you can see the level of significance with each of these. Now, with all of these variables, if we were testing at a 0.05 level of significance, we can see that all of these variables are going to be significant with the exception of the gender binary. So it looks to me like the gender binary field, gender does not significantly impact my output variable of BMI. So if I were to redo this model, I would rerun it excluding the BMI, the gender binary, and we can see that we'll probably have higher levels of significance with the other variables. So let me do that. Let me remove gender because it doesn't appear that gender contributes to this model, to this regression model. And so let me go ahead and remove that. And I'm going to rerun my multiple linear regression. And we can see that all of our variables are now statistically significant. So we can include them in the model. And if we needed to assess our correlation or multicollinearity, we can see here, and we can see our overall model is significant and each of the individual components that are contributing to the BMI multiple linear regression model. Okay, well, I hope this was helpful to you. And thank you for watching this video. And we will see you next time. Take care. Bye-bye.